The nitrogen of a typical amine is sp3 hybridized, which means the bond angles between a nitrogen and the adjacent carbon atoms would be very close to 109 degrees, which is what you expect for a tetrahedral atom. Here's a simple example with trimethylamine. It has 3 methyl groups on a nitrogen. The bond angles between these methyl groups would be roughly 109 degrees, perhaps slightly smaller because of the lone pair needing more space. The lone pair would be in an sp3 hybridized orbital. An amine that has 3 different substituents on the nitrogen, for example, a methyl, a hydrogen, and an ethyl group, should theoretically be a chiral molecule. However, the 2 enantiomeric forms of that chiral molecule will rapidly interconvert through a process called lone pair inversion or pyramidal inversion. Here's an example of a theoretical molecule with a nitrogen that has 3 different groups. It also has a lone pair. The lone pair can be treated as a 4th group, and since all 4 groups around the nitrogen are different, the nitrogen is considered a chiral center. That means there's 2 possible enantiomers for this molecule. They're shown on the left and on the right. These 2 enantiomers will rapidly interconvert through a lone pair inversion that goes through this intermediate that is sp2 hybridized and is planar. Amines with fewer than 5 carbons are generally water soluble, and this is also true for most polar functional groups. If the carbon to heteroatom ratio goes beyond 4 or 5 carbon atoms per heteroatom, then generally the molecule starts to become more organic soluble rather than water soluble. Primary amines and secondary amines contain a hydrogen attached to a nitrogen, and therefore they're capable of hydrogen bonding. As a result, they generally have higher boiling points and water solubility than other functional groups that are not capable of hydrogen bonding. For example, tertiary amines, because they do not have a hydrogen directly on the nitrogen, they are not capable of hydrogen bonding.